Okay, this is a video for the vice grip. This part, the jaw. So before I'm starting this video, I'm gonna talk about how to import IGS into your NX. So we have uploaded some IGS files for this model. IGS file is basically just a geometry file without all these steps. So with this file, with this IGS file, you will be able to measure what um, uh, take measurements on this on my model. So if you have some, you don't know how big this hole is, or there's some confusion in the slides, then you can take a look at the IGS file. So first, let's say how to import the IGS file. Basically, you want to first build a new file, okay, and just import IGS. And one thing you have to change is on the third tab, advanced. You have to no, you don't have to, but it's better idea to check this one, automatic sewing surfaces. So the IGS file will actually become a solid body instead of multiple surfaces. Okay, now then you want to find your IGS file. So I have this one here. Then just say OK. Now it'll import the file into your NX, and as you can see in this part navigator, I don't have any history or sketch how to make this one. However, we can use measurement tool. Then you can say I want diameter of this hole, and what about the overall length of this project of this part. So I can use projected distance, and I want the distance on y direction from the origin. Okay, well, I just pick from here the absolute origin to endpoint, maybe this point. No, so that's the total height, not total height, but from the origin to the bottom. That's the distance, and you can change the second point to anywhere you want. Maybe center of your arc. I can pick this one. So you know how far away this this hole is from x-axis. So that's how we use the IGS file if you need it. Okay, now let's continue to our modeling part. So for this part, the teeth and this ladder here are not required, because sometimes it's too tedious for this piece. And if you like to, you can actually put your name here, whatever letters you like. Okay. All right, now let's start the steps. This one is actually pretty simple in terms of the steps. Just a couple extrudes the base, and you have to extrude this jaw, which is a little bit thicker than the base. Then you need to cut this off, or if you like to, you can extrude the thicker piece and extrude this piece. So this one in real life is used as a cutter, or not so good cutter. And then this piece where the spring goes into is another extrude, and you need to extrude from sideways from this XZ plane to make this tapered, and that's pretty much the steps. Okay, then so to start, you need a sketch for the general, the biggest sketch for this base. Okay, so I'm gonna start a new file and save to someplace. and start a new sketch on XY plane. So I want to zoom in my slides here. Okay, by the way, there are a lot arcs, fillets going on here, and most of them are aesthetic. So as long as you can make sure the holes are at the right position and their size is right, then that's pretty much good. As for example, at the back of this jaw, it doesn't matter if this goes out a little bit more inside. So anyway, how do we start? Usually we start from those assembly dimensions, like this hole here, P5, 0.219. Okay, and I guess that's actually not 0.219. Okay, because the NX rounded things up. So if you have the IGS, you can measure this distance. The diameter is this one is 21875. I think maybe it's 30 seconds. I'm not sure. Anyway, so 0.21875 and the fit, so I know the scale of my sketch. Then there's another one here. Okay, that's 5/8. Okay, that's the bigger one. So the smaller one looks like there's an equal sign there, so it'll be equal. And I can make this and pick the two arcs, and there's a equal radius constraint. And also we have a reference line here. Okay, let's turn on the snap to arc center, and there's a horizontal line, which actually this one is the center of this fillet, and also the center of the hole that the spring goes into. I'm not sure if this one's necessary, but you know, when I was drawing this thing, I have to take multiple tries, so I'd probably have some, you know, unnecessary lines over there. So turn them to reference, and this line has an angle of 75 degrees from y-axis. Okay, so 75 degrees, and the length of this, and that'll be the length, not the horizontal dimension. So 1.125, and this is P8. Okay, how to move this thing around 0.6, 0.6, and okay, now we can add this circle P10. P10 is 0.375. Okay, then two lines that goes tangent from, no, we need this bigger circles here. The bigger circles here is 625 and 625, okay, which is 5/8, and that's the same here. Then we can draw a line which snaps to this on curve snap on the arc and to here, and you want to make sure this is tangent, and also do the same for the other side. And if that goes this way, you can just go back to the circle and make this tangent, or just, you know, you can always drop the line first and make this tangent later. Alright, then trim this off. There's something here because we have this reference line, so we can trim this off as well. And what's next? Next we can go from this, and the right side looks like a little bit complicated. Okay, so we have this geometry, and what we do is we can just go for something like this horizontal line and another line, and I don't want constraint, so you can hold down Alt key. This will force NX to not add any constraint on your line. Okay. And now I can add constraints. Constraint point on curve. I want the very tip to be on y-axis. So the point and the y-axis. Okay. And then I think that's good enough for now. Dimension for the top 0.18. Okay, the constraint still there, and we have 77 degrees. Okay, that's 77. Okay, now let's try to drag. Okay, and there's we can still move up and down, so we need a total height from origin, which is P0 3.6 inch. Well, I'll pick. It's better to pick the line instead of the point. And pick this horizontal axis, 3.6 inch. And as you can see, it says fully constrained, I think, for this part, except the length. So for this arc, we can probably get away with fillet. So that's 1.2 radius, 1.2. Hit enter. Click this line. Click the arc. I want to drop it here. Yeah. So fillet is easier than 3-point arc. Now we can trim this off, or you can do this to the last. Alright, now this side is done and still fully constrained. That's pretty good. Then we can move down from here or from the bottom. If we try to start from the bottom, what we will do is there's a circle here. Okay, and if this circle looks like it's on y-axis, then it's on y-axis. Now we can drop this first. The radius is 1/8, so diameter is 1/4. Then put this on y-axis. Next, we need to get this part, or maybe not this part. We can go straight up first because there's no dimension here. Yeah, we only have the dimension here, and it looks like all the dimensions they're generated from the top. So actually it's better to start from the top, because if you look at those 3 vertical dimensions, they all start from the top. So that means the top is your reference plane for those dimensions. So I'll just leave this alone and go down here. And that's 3.5 degree. That's the angle between this and the y-axis. Okay, let's try to hover to the vertical axis here, and 3.5. We can drag this out. Alright, now there's P16, which gives the Actually, I can just click on the line here. That's a vertical dimension, 1.56. Okay, and here it's actually the step. I made this step because the top teeth I would use subtract, to cut into the solid. The bottom is harder to use subtract method, so I use I added the teeth onto the solid. So the top is subtract, the bottom is unite. Then that's why I need this step down here. This is actually the bottom of the teeth, and for the top, that's the top of the teeth. Anyway, it's not required, so if you have interest, you can try them out. And here, I'm not sure if I have a detailed view here. If not, I just go from here. There's 120 degrees, like this, and the dimension here is 0.05. That's actually the height of a teeth. So let's zoom in here. 120 degrees, and that's should be, if it's 120, and let's take a look. Okay, alright, forget about that short line first. Let's move down first. Then there's P21 for the circle that has diameter of 0.2, so we have 0.2 diameter circle, which is on the y-axis, and there's the dimension 2.5 and 2.4 to the top. 2.4. Okay, then there's also a 3-point arc, so connecting the circle and this line. So from the end point to this tangent point. Oops. So I didn't wait till the tangent sign came out. We can add tangent constraint for those two here. Then lastly, we can close this, and we can use this quadrant point. You want the bottom point. Oops, straight line. Okay, so now we can trim this off, and we have to leave that. And also we want to make sure this one, the vertical line, is on the y-axis. So y-axis and the vertical line collinear. Okay, and what's next? Okay, we have this dimension here, P19 is 0.19, so we can move this a little bit. Not sure if I have okay, don't have anything here. So the arc to the vertical line, which is actually y-axis, should be 0.19. Okay. Then I don't need this tangent here. Sometimes NX will add constraints automatically, so don't want that. Okay, and that's my 0.05 short line here, which is supposed to be the center of a teeth. Alright, now it's hard to see on the slides. Actually, this arc goes through the end point of this, the height, and let's try to use point on constraint, a point on curve, and so it's not good because I have a horizontal here. That's still not good. Try to go back, and let's move this line to its position where it's supposed to be. So, oops. Okay, so it looks like this. So, and I tried a couple of times. You have to make this line tilt up to be able to get the proper shape. I don't know why, but maybe this is too complicated, the sketch. So let's point to the arc, and I got successfully add this only when this line goes up. So it's better idea to tilt up this line, or you can just leave it alone because this really doesn't matter unless you want to add teeth here. Okay, so I think our sketch is done here, and finish the sketch. Now we can move down to the extrude. Alright, extrude, and infer dimension, infer curve, or region boundary curves, that's all the same for this case. So I would use symmetric. So total thickness is 255.255 divided by 2, and hit enter. That'll be the major part of this jaw. And then next, we need to cut this cutting blade here. So that we would need another sketch. I hide this first, create another sketch on XY plane. Okay, and we do need the first sketch to be here. So let's take a look at this second sketch. So we can snap to the first sketch in the second sketch. Alright, now that's the midpoint or the quadrant point of this arc, and it doesn't matter how much this goes out, okay, because all we need to is to cut this portion of the solid. So we can go starting from here, go out, and this does matter, but we can add dimension later. Yeah, I believe those two are fillets, so we can add dimensions 0.5, and the height is 1 inch. Then this P26 matters. It's how much you will cut into this. So it seems like I cannot give dimension between two sketches. What I can do is I can project a curve from the first sketch, and I just need one, so I will use single curve and pick this one, click OK, and you don't have to do anything on this curve, or if you would like to, you can change this to reference. And now we actually don't need the first sketch anymore. You can just hide it. Okay, and that's there because we have those two lines has a relationship with that arc. I think that's tangent and point on curve or something. And now we can have dimension here, 0.3, and funny I don't have dimension for this. And let's see. So I guess it should be flat here, but let's try it first. Fillet 0.06, okay, 0.6, this corner and that corner. And let's try to make point on curve constraint to pull down this step. Okay, so I guess that's the way it should be. I should have a point on curve constraint here. Alright, and that's all for this sketch. Okay, let's take a look at the block here and extrude. Okay, so here we're gonna play with the distance a little bit, and let's see. So we need to leave some volume in the middle, and that blade has a thickness of 0.1 inch. So we're gonna start from 0.05 from the the symmetry plane and go all the way up. So this value here is actually doesn't matter. You can just pull out outside of the solid, and here you want subtract from that body. Okay, so this will cut something like this. And now next two method, you can mirror feature, mirror this extrude to the other side. Okay, or you just extrude this thing again. So you can do extrude the sketch again, put a negative sign on both numbers, hit enter, and then that's the other side. Okay, so we got 0.1 inch in the middle for the blade, and the blade should be chamfered, so because it's a sharp blade at this side. So chamfer, and we know the thickness is 0.5, 0.1 inch, so half is 0.05, and pick those two edges. Okay, this will give us a sharp corner for the edge, for the blade. Now next step, it's just the bigger, the thicker jaw on the top. Alright, now let's hide the solid. We need the first sketch again. Don't need the second sketch. Okay, so if you zoom in this picture, it starts from, I think, the intersection, the connecting point between those two arcs. So first sketch, again, that's on XY plane. So we got multiple sketches on XY plane. Okay. Now a 3-point arc, or we can project the lines first. If you notice the color difference here, because we need to extrude this loop, okay, the top loop. So single curve, I need extrude, project those curves, and probably not the shorter arc here, just the longer arc. Alright, now we can hide the first sketch to give you a better view here. Then first, I made a vertical line here as a reference, then 3-point arc starting from here, ends there, and also tangent there. And lastly, this is perpendicular to the vertical line. So perpendicular for the arc and the vertical line here. Now that's fully constrained except the length of this reference lines. It doesn't matter. Okay, so you would say we have something sticking out here, but doesn't matter. If we're gonna extrude this, even inverted curve can do it. Sometimes if you can't, okay, if it says the input section is invalid, you can use region boundary curve. So basically this is just picking up areas. So if I can pick this area and then extrude, 0.2 symmetrically. So 0.2. Okay, and actually within this extrude, you can unite this piece to the first extrude. So you don't have to do that in another command. Okay. Next, the head is actually tapered. The jaw head, the tip. Okay, it's not uniform thickness. So it's pretty simple just to make some extrude from this side, this view. Okay, so what we do is we build another sketch. Only difference this time we build this on XZ plane. Yeah, hit OK. Also, I need the solid to be there, so I know where my line starts. So if you look at this sketch from an angle view, we have this starting point for the bottom line here, or the cutting line, and another point. They're snapped to the solid. How do we make this? We just snap from within the sketch, snap to this point, and snap to this line or this edge on the solid, on curve. Okay, and then you can go up as long as you can cover this portion of the volume inside your closed loop. So I'll go like this. Okay, and now we can add dimensions. There's only one dimension that matters, is this one, 0.1 inch. Okay, so from this point to the middle, which is the axis. So I'm gonna click on the horizontal axis and 0.1 inch. Okay, now that's all for the top. I can do a mirror curve to make copy the top half. And mirror curve, I want connected curve for this somewhat like a rectangle, and the symmetry line is your x-axis. And that's all for this sketch. So you can now extrude this 2 into the solid, just as long as they can go past the solid. And here you want to choose subtract. Okay, and OK. So now it'll taper the head. And lastly, we have a little ear here that will allow the spring to hold this jaw. So, which is on the next slide. Okay, and I'm gonna hide the solid again. We need the first sketch and build another sketch on XY plane. So we have like 3 or 4 sketches on XY plane. Now we do need this bottom line here to extrude into a solid. So again, we're gonna project single curve. We're gonna project those 3 curves into our sketch. Then we can hide the first sketch. Okay, and there's a circle for the hole. Let's see, it's 0.14 inch diameter, 0.14, and there's a fillet here. Let's see. Okay, that's not actually a fillet. This was a circle to begin with. So a circle which has a diameter of 0.3125, and over constraint because it's automatically at a tangent here. Just click delete that. Okay, and now we can add those 2 straight lines, and you can touch this line and want to make this parallel to that line. Okay, and it's adding perpendicular and parallel, which is obviously over constrained. So what we can do is delete that perpendicular. So I want this line to be parallel to this side, and also this line to be parallel to this line. That's parallel. So trim this off. You don't even need to trim those two legs. What you can do is you can finish a sketch and extrude. You can use region boundary curve, pick this area and enter the value, which is 0.05 symmetrically. And also I want to combine this to the existing solid. So that's all for this jaw. So if you want this part to look nicer, you can continue watching this video. And next step, we're gonna add the teeth and some leather on the part. So the teeth is here, and we're gonna extrude one teeth for the teeth in this arc. And considering this top and the bottom surfaces, they're not parallel, and you can't extrude something into that. You have to be, the top and the bottom of your extrusion has to be parallel, or you can have some face to limit its top and the bottom. So it's just easier for me to take out this tapered head and recover this into the original form. So we're gonna find this one, which made the tapered head, and I'll suppress that. Then after I made the teeth, I can call this back, or I can simply just delete this because that's just one extrude, and start working on my teeth. Okay, so for the top half of this teeth, it's gonna be subtract into the solid, and the bottom we're gonna extrude one tooth and pattern this along this path. Okay, so another sketch again on XY plane. So XY plane, okay, and we don't need this. We can hide the stuff we don't need and call the first sketch back. Okay, and that's how you suppress or delete the extrude. Okay, so it's here for the top. That's actually smaller teeth on the straight portion, and we need this line from first sketch. So again, we're gonna project this line as well as this line for the bigger teeth. And if you zoom in, oops. So this one starts from the end of this bigger arc. So I just need those two arcs, and I can hide the first sketch. Alright, now we're gonna work on the smaller teeth first. So this one will be cut into a solid. So I'm gonna draw on the left side of this line. Okay, make sure it starts from the end point and ends on the curve. So you want to see those constraint points, and we want to make sure those two are the same height. And also you want to make sure this is actually a 60-degree teeth. So we need to add dimension for this side, and you don't want vertical. So be careful, you don't want this, you want this one, the distance between them, to be 0.05, and that's pretty huge. Okay, and now we can add another one, 0.05. So all three sides of the triangle is the same, are the same. Now that's definitely a 60 degree here. Then we can pattern those two curves. So pattern curve, and that's a straight line linear. I didn't use pattern for the bigger teeth at the bottom because there's no option for me to pattern this along a path. But that one is in this pattern feature command. Anyway, so this is a linear and pitch 0.05. Okay, pitch is distance for each unit. So that's 0.05 and the 31 teeth. Linear object is this one, the line from sketch 1. So we haven't picked up the curve we want to pattern yet. So pattern this, and that's a wrong direction, reverse the direction. Let's take a look at the top. Okay, so 31 should be fine. 32, it will go outside of your solid. So I just use 31. And okay. Alright, now that's for the top. We need to make a, well, we also need to close this curve. So now it's a continuous connected curve on the side, but it's an open loop. And what we need to do is either we can use this, however this area and this area, they're not connected. If you use region boundary curve, you have to click on each single tooth. So what I do is I made a 3-point arc here because that's just 3 click. One here, top one here, then something like this. So I can extrude this part. Okay, this is a closed loop here. And for the bigger teeth now, again, that's a 60 degree. And this is supposed to be okay. Alright, now make them equal. And the back side, that's a 3-point arc to make this close the loop. Okay, and dimension for this, the height is 0.05. So I need to make a height, and it's not there. So I need 2 construction lines or reference lines. And it's hard to snap to here because it's wanting to add a tangent there. If you click, it flies away. So what we do is we can just drop it anywhere without any constraints and add a constraint, just one. That's all you need. And turn this line into a reference. And actually, yeah, we need this. Okay. And draw the height of this triangle. Turn this to reference. That's our height of this tooth. Okay, so 0.05. And make this 60 degrees. That's a 60. Okay. So I don't need to pattern this because there's no way to pattern this in the sketch. Okay. Yeah, I can finish the sketch. So call out the solid. Now extrude for the top portion. Okay, maybe connected curve, but that's a closed loop. Okay. Now it'll pick this this arc without the teeth. So I'll use connected curve. Okay, it's not picking up the right ones. And deselect. Let's try single curve. Box, select everything. Okay, still not good. Alright, now just turn this back to reference and get this done with connected curve or region boundary curve. Now that will all work. And you want symmetric direction, and also subtract from the solid. Okay, so that's for the smaller teeth on the linear, on the straight portion. Then another extrude for this little one here, and I believe I still need to, well, we don't have to because that's just 3 curves. So single curve, the arc, and those 2 sides. Symmetric. Now it should be the same as the height of this step here, so it's 0.2 I believe, and okay, and they are united as you can see here. So next I'm gonna pattern this tooth along this path, and pattern feature is here. So you're actually patterning an extrude instead of a solid. So that's a feature, okay? And we need to pattern this along a path. So you need to pick a path, which is this line. Actually, you want a single curve. I just want to pattern this along this curve here. And don't worry about the alert. Can still make it. So the count and the span, I want 16 teeth along this path, along this 100% of this total length. And you can just say okay. Okay. So after we make the teeth, we can taper the head. So all we need to do is just extrude that sketch again. So we're gonna extrude this sketch again. To pick the whole sketch, we can use invert curve, pick this, and cut into the solid, subtract, and okay. Alright, now that's for the teeth, and there's some letters here, and so first you need to draw the box or the letter. So I'll make a sketch on this face. Now this time it's not XY plane, it's the top face, and the coordinate system is not bad. Okay, actually the box is kind of parallel to this line here, so that's okay. And we need a box. If you want to add dimensions, you can do that. And I'm gonna measure what's the diameter of this. So it's kind of not a nice number. I'll say 0.2. Okay, it's a little bit small. 0.25. And this is okay, 0.6 maybe. Alright, then drag it anywhere you want. Okay, that's for the box. Then we're gonna insert a curve, which is the text. So insert curve and text, and that's the mark on the plier, on the grip. You can change to whatever you like. Your name, okay, your initial, anything. So anything, and different fonts. I'm gonna specify a point. You can specify this point. Okay, and now you can rotate, and Notice in this window, the snap to 45 degrees. I can snap to 5 degrees. So it'll give you a smoother adjustment. You can even change that to 1 degree and drag this around to see how this fits. Once that fit, you can drag X and Y direction. Okay, I think my ladder is pretty good because I changed this length and height already. At the beginning it was like really huge, so you can play with this numbers here. That's the ratio. 100% is it's up to ratio of the original font. If it's 200%, just squeeze the wider. So you can play with those options and say okay. So now we have a curves on the top of this surface. Now we can extrude this. So actually we want to etch into the solid, something like this. We can play with the curve rule. We're gonna use region boundary curve, so we can pick this area. And some letters, we have another closed loop. And now we can switch the direction, make it really shallow. I think 0.02 maybe. Yeah. So that's your letters. And if you want to make this more realistic, you can add a lot edge blends. And I added something called a draft. If you look at the real piece, this face here is not actually vertical. It's a little bit at angle to this face. So okay, draft is just make it like shrink or expand, and there are a lot options. The vector is hard to explain, just try it. Stationary face, I'll pick this face. Face to draft. Okay, stationary face should be the face not moving, right? I'll pick the top face. Face to move this face. Okay. You don't want tangent face, it's gonna pick up everything. So single face, let's want this, and there's your angle here. Let's see. I'm gonna look from this side. So now you can tell the difference from the bottom and top. If you want 15 degrees or 16, let's try 15 degrees. So it's a little bit visible. And the thing is, 15 degrees is from the top surface, so you can't really do two surfaces at the same time. You have to do this twice, or you can mirror feature, insert mirror feature, and which feature is the draft existing plane. Okay, that'll be our XY plane. Click OK. Fail to update. Okay, so it doesn't like it. Now what we do is we can just redo this again. Vector, the direction. I guess that's the the starting where the angle starts. Stationary face. I'm gonna move this face, and so the angle is wrong, so I will use negative 15 degrees. It comes out instead of goes in. Okay. Alright, so after this you can add edge blends, and as you can see we can pick this edge, but it's not tangent here. So if you want to add edge blend, usually you want your edge to be tangent. So I'll make this tangent first, but you want to make this a little bit smaller. So 0.2 is probably okay. Then pick the other side and apply. So with this edge blend, this long edge is tangent now. So I can pick this one. Again, you want a smaller radius. And the same for the other side. And okay. And if you notice, I have a pretty big radius over there. So if you like to, you can just change all the radius as you wish. So and the little ear here, there's a big edge blend between those two. So something like this, and some edge blend at the top and the bottom of this connection. Apply, just to make this look nicer. Okay, so I guess that's all for this part. You can also edge blend those letters. All right, thank you.